In this video lesson, we will learn about cylinders and prisms. So first I'll define what these are. This here is a prism. We call this a hexagonal prism because it has two bases, both of which are hexagons. In general, a prism can be anything. You just have to have a base, and then it sort of vertically or horizontally it expands. Like I have a triangular prism here, or I can have a rectangular prism. So it's just two identical bases at some distance from each other in three-dimensional space that are connected to each other. And a cylinder is kind of like a prism, but the bases are just circles. So cylinders are kind of like pipes. So now we're going to talk about how to calculate their volumes. So we always have a base, and then it somehow extends upwards, and then the same base. And to calculate the volume of these, it's important, first of all, to calculate the area of the base. V equals the area of the base, capital B, times the height. So here we have the capital B labeled in the hexagon, and capital B is the base area, and the base could be any shape. It could be a triangle, it could be a rectangle, it could be anything. It could have 12 sides. As long as you can calculate its area, you can figure out the volume of the prism. In a cylinder, the same is true, that it's B times H, but we can actually calculate the base area based on the radius, because a circle has area pi r squared. So the volume is always BH, and when you have a cylinder, it's pi r squared h, which is also BH. So now we're going to do a few examples. So in this example, we need to calculate the volume of the cylinder. So the first step is the base. We recognize that the base has area pi r squared. And in this case, r is equal to 7. So we plug in 7. 7 squared is 49, so I get base area of 49 pi. And the height is 6, because as you can see, it's labeled here as 6. So that means the volume, which is B times H, is 49 pi times 6. And this equals to, I'm going to give a decimal. We just plug this into our calculator. It's 923.63. And that's the answer to the problem. So the first step is always calculate the base area. The second step is multiply by the height. Another example. The base of the prism is a right triangle. Find the volume. So first I'm just highlighting here, we have some right angles. So what that means is nothing much important, but we are able to calculate the area of the base more easily because of the right angle. And 6 is the height. So let me elaborate. Here's the base. It's this right triangle, and it's got given side lengths 3 and 4. And because these are the legs of the right triangle, and because it's a right triangle, we can easily calculate the area just by multiplying them and dividing by 2. So we get base is 1/2 3 times 4, the base area. That's 12 over 2, and that's 6. So the fact that it's a right triangle just made the area calculation easy. Now we have that height, and it's labeled as 6, so we multiply our expression by 6, B times H. We get volume equals 6 times 6, or rather, I'll write out the whole formula. It's B times H, and both of these are 6. Multiply them together, and we get 36. All right. A cylinder and a square prism of equal volume have height 7. So we have a cylinder and a square prism. And if the base of the prism has side length 3, then find the radius of the cylinder. So there's a lot of info here, and we need to figure out what goes to what. So first, let's draw the prism. So here I drew the square, the base, and now I'm drawing the vertical connectors to the other base. And there it is. It looks something like that. So it's got height 7, and the base of the square prism has side length 3, so I labeled all those 3s. And what we want to do is calculate the radius of the cylinder, knowing that the height is 7 and the volume is the same. So first we want to calculate the volume of this prism, because to find the radius of the cylinder, we'll need the volume. Since the volume is the same as the volume of the prism, we calculate that. So the base area is just 3 squared, which is 9. That's easy to calculate because the base is a square. And the height is 7. So the volume of the prism is 7 times 9. V equals BH, which equals to 9 times 7. And 9 times 7 is 63. So that is the volume that we were working with. So now we're going to forget about the prism, and we're going to look at the cylinder. So we're told that the cylinder, what do we know? It has height 7, and it has equal volume. So here I'm drawing the cylinder. It's got unknown radius, so we're labeling it as R. It has height 7, as I said, and as is written in the problem. And volume is the same as the volume of the prism. But the volume of the prism we know. So first, to calculate the volume of the cylinder, the base is pi r squared, and the height's 7. So we can calculate the volume of the cylinder in terms of r. We get B times H, which is 7 pi r squared. And this volume is equal to the volume of the prism that we calculated earlier. So I'll write this up here. So what does this tell us? If VP equals VC, then we can rewrite this as 7 pi r squared is equal to 63. Or 63 equals 7 pi r squared. So now we just have to solve. We divide both sides by 7 pi. On one side we just get r squared. And on the other side, 63 over 7 pi, which equals to 9 over pi. So then r is equal to the square root of that. Square root of 9 over pi. And this we can just plug into our calculator and it'll give us a decimal. Specifically 1.69. That is the radius. So that's how we calculate volumes. Well, I hope this video lesson was helpful. Thank you for watching.